quadrilaterals. So if you are struggling with this homework, please make sure that you click, if you log into our Google Classroom, so this video may be a little lengthy, but you're going to log into our Google Classroom, guys. You're going to come down to whatever hour you are in for me, guys. And then you're going to come, if you notice, if you go to parallelogram proof homework, I did include hints for parallelogram homework. And so this allows you to actually figure out, okay, if I'm talking about a parallelogram, what do I need to prove? What do I need to show? So let's go back to the homework. All right, so they asked us about a parallelogram. I've already graphed my quadrilateral, right? But they say they want us to prove that this quadrilateral is a parallelogram. So I will prove that this is a parallelogram by demonstrating one of the following. Let's look at it. If it's a quadrilateral, then the defining feature of a quadrilateral is that the opposite sides are parallel. There are actually 3 ways you can prove it, but one of the easiest ways is just to prove that the opposite sides are parallel. You also can prove that both pair of opposite sides are equal in measure, so that means you would have to find out the distance of all the sides. So you can do that if you prefer, using Pythagorean theorem, constructing your triangles, and labeling those sides. So that's an option. You also can choose to say that one pair of opposite sides are parallel and it's equal in measure. So that may be another option. But what I'm going to choose to do this time is I'm going to prove that the pairs of opposite sides are parallel. So all I need to do is figure out what is the slope of these lines, and then if I know what is the slope of these lines, then I am able to figure out whether or not it's a parallelogram. Now guys, there are 2 options you can choose when using this, guys, to figure out if it is the slope. And so parallel lines, I have written this, parallel lines have the same slope or equal slope. So as long as we show that these opposite sides have the same slope, we're fine. And so what I'm going to do is I'm going to get the slope. First of all, I know my slope formula is y2 minus y1 over x2 minus x1. And over here to the side, I'm just going to kind of list the points so I don't have to toggle back and forth. But O is -9 and -1. And I know that point R is at -5, 3. I do know that the first line that I chose to find the slope of is going to be OR. So if I'm looking for the slope of OR or RO, right, I need to first look at y2 minus y1. So I'm going to let my R be y2. And so I'm going to say 3 minus a -1. And then on the bottom, I'm going to have -5 minus a -9. When I simplify that on the top, I'm going to have 3 minus a negative. That double negative becomes 3 plus 1, right? So 3 plus 1 will give me 4. -5 minus -9 will give me 4 as well. And so then I'm going to have 4 divided by 4, which is 1. So that's my slope of OR. But I'm looking for the opposite sides. So the opposite side of OR is QP. So that's what I need to verify. If it's a parallelogram, then those opposite sides are going to be parallel to each other, which means they'll have the same slope. So I'm going to come here and also calculate the slope of QP. If QP is parallel, then I'm going to go ahead and drop those down. So I know that's OR, and then now I'm talking about Q and P. So I have Q at 4, 1, and I have P at 4, 1. I have P at 0, I have P at 0, -3. So now let's calculate the slope of QP. Well, QP, let's go ahead and do our calculations real quick, because QP, I know that I'm going to let P be my y2, right? And so they're going to be negative, so QP -3 minus 1, and then we'll have 0 minus 4. -3 minus 1 is going to give me a -4. 0 minus -4 will give me a -4. So that tells me 1. So now I have already figured out that I have one pair of opposite sides. So this showed me I have a pair, at least one pair of opposite sides. But that's not enough. In parallelograms, you got to prove both. Now, guys, in addition, you can simply do rise over run. So you could have said rise 1, 2, 3, 4, run 1, 2, 3, 4. And so my slope from O to R is 4 over 4, which is going to be 1. Simplifying down. So you could do that as well, guys. Use rise over 1, but I'm going to continue to use the slope formula just so you guys are getting a little bit more comfortable with that. Now, we also need to prove that RQ and OP have the same slope. So what I'm going to do is I'm going to come here and start off with my slope formula again. Remember that up here, our M, we have y2 minus y1. So again, I'm talking about the Q and R. So I'm going to be looking at Q and R, which are going to be these two, right? So let's go ahead and start working on finding the slope of Q and R. So I'm going to highlight those two. So I'm going to let 1 be y1, so I'll let R be y2. So I'll say 3 minus 1 and negative 5 minus 4. So 3 minus 1 is going to give me a positive 2, right? But negative 5 minus 4 is going to give me a negative 9. So my slope here is going to be negative 2/9. All right, now I'm going to look at my slope for OP. All right, slope of OP, now I need to look at O and P, points O and P, right? So I'm going to come off to the top. I'll let O be my y2, so I'm going to say negative 1 minus a negative 3. And then after that, I'm going to also, on the bottom, subtract my y's. So that's going to be negative 9 minus 0. So on top, I got negative 1 minus a negative 3, which becomes negative 1 plus 3, negative 9. And so I know that's going to simplify down to a positive 2 over 9, which is ultimately still negative 2/9. And so now I have my second pair of opposite sides. So again, once you know that your opposite sides are parallel, then you are good. Okay, now you have proven what you need to see, right? They want you to prove it's a parallelogram. So I'm going to scroll down here and say I've demonstrated that this parallelogram, this quadrilateral is a parallelogram because we have both pairs of opposite sides are parallel. All right, now they want you to demonstrate what is the slope. So the slope of OP, I'm going to come back to my notes. I have negative 2 over 9. All right, and then I have a slope of PQ. My slope of PQ is going to be 1. My slope of QR is going to be negative 2 over 9. And then my slope of RO is going to be 1. And so again, negative 2/9 for OP, 1 for PQ, negative 2/9 for QR, and 1 for RO. Okay, so the slopes of any pair of opposite sides are equal. And that being the case, those sides are parallel. And so therefore, this is a quadrilateral. This quadrilateral is a parallelogram. And so now you can go ahead and submit your answers. And there you have it, guys. That is how you do a problem like this where you are proving it's a parallelogram. You can prove the opposite sides are parallel. Another option, guys, you can simply count your rise over run. So like I did from O to R, it was rise of 4, run of 4. And so therefore, that slope for OR is 4 over 4, which is 1. If you counted the slope for RQ, you would go over 1, 2, 3, 4. Well, you were going to first rise. So from Q to R, right? So I'm going to go down 1, 2 units. So rise is negative 2. And then I'm going to run 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So again, you could have used rise over run as well to find your slopes.